Right, so the measurements that you would need to take in order to work out the refractive index of a glass block are the angles of incidence and the angles of refraction, which we're going to measure using a protractor, 1 mark for each. Describe how the student would use these measurements to find the refractive index. Well, the refractive index, which we give the symbol N to, if you're using the symbols, you need to make sure that you've defined them and told me what they are, is equal to the sine of the angle of incidence divided by the sine of the angle of refraction. And if you've done that, you get both marks for that part. The next part is looking at a section of a bicycle reflector. The ray of light is incident on a flat surface, so at this point here the ray of light passes straight through because it's passing in along the normal, and what we're looking at then is that you've got to continue the incident ray in the diagram to show the path of the light until it emerges. Well, will it emerge at this point here? Okay, and the answer is going to be no, and the reason being, well, if we draw in our normal line, the normal is always going to be at 90 degrees to the surface. Okay, and we look at this angle here. This angle here is going to be at least 45 degrees. Okay, now if it's 45 degrees or more, then we're going to get total internal reflection at that point. So none of the light is going to escape. It's all going to be reflected internally. Okay, now then it's going to hit this next point here, and again really we need to draw a normal line on here, and again our angle of incidence is going to be big, and so because it's bigger than the critical angle, we're going to get total internal reflection again at both points. So you're going to get 1 mark for showing your total internal reflection at this point and 1 mark at this point. It would be good if you've got the normal lines, but we won't take a mark off on this case if you haven't. Okay, and you only have to show it up to this point here until it emerges from the plastic. It will keep going straight again because it's passing normal to the boundary. So that's those 2 marks here. What happens to the incident ray as it enters the plastic? Well, it's still going to be slowing down. Even though there's no bending of the light, okay, we're still going to get a decrease in speed. And that decrease in speed is also going to cause a decrease in wavelength, so either of those two. The frequency of the waves is going to remain unchanged though. On the mark scheme, it accepts a mark if you say that it refracts at this point here. Okay. Now I personally am not that keen on that. I don't think that it's refraction unless the direction changes as well as the speed. So rather than getting into that, stick with the fact that the speed decreases or the wavelength decreases.